Hi, welcome to Bits and Proofs. Today's a foundations lesson. What is AI? LLMs explained simply for beginners. AI is everywhere around you. You realize these days that your phone finishes your sentence you start typing. A chatbot answers customer questions with no human intervention. A model writes code for you. A tool summarizes a 10-page report in seconds. AI is all around us. But most people who use it every day cannot explain what it actually is. By the end of this video, you will be able to explain others. First, let us clear away some confusion. AI is not a thinking robot from a science fiction film. It does not understand the world the way you do. It is not conscious, dangerous, or alive. These ideas come from movies, not from the real technology. What AI actually is a mathematical function trained on data, software running on a computer in a data center, making predictions. Here is the simplest way to think about AI. It is a prediction machine, a system trained on examples that predicts the most useful output for a given input. Data in, prediction out. Look at these three examples. You give text of an email, it predicts spam or not spam. You give a photo, it predicts cat or dog. You give a question, it predicts a helpful answer. These are very different tasks, but they're all the same underlying idea, different training data, same mechanism. So what can AI actually do today? There are four main areas. Text, write, summarize, translate, answer questions. ChatGPT explains a complex topic in plain language. Code, write, review, and explain code in any programming language. GitHub Copilot completes a function as you type. Images generate images from a text description. Midjourney, an AI image generator, creates a product photo from words. And reasoning work through multi-step problems step by step. For example, plan a 3-day trip to Tokyo on a $500 budget. This playlist focuses on text and language models, the category you will build with most often as an AI engineer. Most AI you interact with today is a language model, a model trained specifically on text. When you chat with ChatGPT, Claude, or Gemini, you are talking to an LLM, a large language model. The diagram on the right shows how LLMs fit into the bigger picture. LLMs are a specific kind of generative AI, which is a kind of machine learning, which is a part of the broader field of artificial intelligence. This playlist is about understanding how LLMs work and how to build real systems on top of them. So what is an LLM exactly? A large language model is a very large mathematical function. It was trained on enormous amounts of text, billions of documents, and that training produced billions of learned parameters, which are just numbers stored inside the model. The interface is very simple. You give it text. It gives you text back. That is all. One important thing to note, each call is stateless. The model has no memory between separate conversations. Every new chat starts completely fresh. Let us look at the two model families you will use most. First, Claude from Anthropic. Anthropic names each model after a literary form. The name hints at its character. Haiku is the smallest and fastest. It is very cheap to run and works well for high-volume simple tasks like classification, short replies, or data extraction. Sonnet is the middle model, balanced speed and strong capability. Most teams use Sonnet in production because it handles the majority of tasks well without the higher cost of Opus. Opus sits just below the top. It handles deep reasoning, long documents, and complex analysis very well. And Fable is Anthropic's newest and most powerful model compared to Opus. It is also the most expensive in the family. Use Fable when you need the absolute best output, and cost is less important. Across all Claude models, Anthropic provides strong safety guardrails and a long context window. OpenAI has two model lines. The first is the GPT family. GPT 3.5 Turbo is the baseline, very fast and cheap, good for simple tasks. GPT 4o is OpenAI's current flagship. The O stands for Omni. It handles text, images, and audio together. GPT-4o Mini is a smaller, cheaper version of GPT-4o with an excellent cost-to-performance ratio, popular for production apps. The second line is the O series O1 and O3. These are reasoning models. They work differently from GPT models. They spend extra time thinking step by step before they give you an answer. This makes them much better at mathematics, logic, and hard multi-step problems, but they are slower and more expensive per response. All OpenAI models are available through the OpenAI API, and GPT-4o also powers ChatGPT. The third major closed model family is Gemini from Google. Google covers every tier from on-device to the most demanding cloud workloads. Gemini Nano runs directly on phones and edge devices with no network call needed. It powers AI features built into Android and Pixel devices. Gemini Flash is optimized for speed and cost, good for high-volume tasks like summarization, classification, and real-time responses. Gemini Pro is the balanced model with strong reasoning across text, code, and images. It has a context window of up to 1 million tokens, matching other top-tier models like Claude Opus. And Gemini Ultra is Google's most capable tier, available through the Gemini Advanced subscription and Google Cloud. One important thing that makes the entire Gemini family different: all Gemini models are natively multimodal. They handle text, images, audio, and video together inside a single model, not through separate add-ons. Beyond the three close families, Claude, GPT, and Gemini, there is a world of open models worth knowing. Meta's Llama is the most popular. The model weights are freely available, so you can download Llama, run it on your own hardware, and fine-tune it for your specific domain. Mistral, from a French company, produces efficient, open, and commercial models that are fast, compact, and popular for on-device and edge deployments. And Google's Gemma is a family of lightweight, open models, useful for research and running locally on limited hardware. The key advantage of open models: full control. No usage costs, no data leaving your infrastructure, and the ability to customize the model however you need. As you build more advanced systems, knowing when to use an open model versus a closed one becomes an important engineering decision. General-purpose LLMs like Claude, GPT, and Gemini handle most tasks well. But there are also models built for a specific job, trained much harder on one domain to be the best at it. The first category is code. Models like Codex from OpenAI and Code Llama from Meta are trained specifically on source code. They are faster and more accurate at code completion, review, and generation than a general model. Codex is what powers GitHub Copilot, the AI assistant built into code editors. The second category is images. Models like DAL-E3 from OpenAI, Stable Diffusion, and Midjourney generate images from a text description. These are a separate model family. They are not language models. The third category is speech. Whisper from OpenAI transcribes audio to text with high accuracy across many languages. 11 Labs and similar tools go the other direction. They convert text to natural-sounding speech. As the AI space grows, you will see more specialized models for specific industries and tasks. This playlist focuses on general-purpose language models, the foundation that everything else builds on. Most early language models handled text only. Today, the leading models accept multiple types of input in a single conversation. This is called multimodal. The four main input types are text, images, audio, and video. Text has always been there. Images means you can share a screenshot, a chart, a diagram, or a photo, and the model can describe it, analyze it, or answer questions about it. Audio means the model can process speech, transcribe it, translate it, or understand what was said. And video means the model can analyze scenes, motion, and events across time. Here are two practical examples. You take a screenshot of an error message and paste it into the chat. The model reads the screen and tells you what is wrong. Or you upload a bar chart from a report. The model explains what the data shows. Multimodal capability makes AI much more useful in real-world workflows where information does not always arrive as text. Now that you know the major model families, how do you choose? Here is a simple framework. If you are starting a new project, use a mid-tier model, Claude Sonnet, GPT-4o, or Gemini Pro. These are balanced in cost and capability and handle the majority of production tasks well. If the output quality is not good enough, the reasoning feels shallow, or the model struggles with complex tasks, move up to a more powerful model, Claude Fable, Gemini Ultra, or the O103 reasoning series. If cost or data privacy becomes a concern, you are processing a large volume of requests, or you cannot send data to an external API, move to open models, Llama, Mistral, or Gemma, running on your own infrastructure. The simple rule: start mid-tier. Move up if you need more power. Move open if you need more control. Where does all that knowledge come from? Training. The model is trained on an enormous amount of text, books, websites, articles, code, billions of examples. During training, the model learns patterns. Which words follow which? How ideas connect. What a helpful answer looks like. The result is a set of frozen weights, billions of numbers locked inside the model. This is the learned knowledge. Training is done once by the model provider. It is extremely expensive. Once trained, the model is shipped as a product and you use it through an API. Using the model is called inference. You send a prompt, the model predicts the response token by token and sends it back. The weights are read-only. The model does not learn from your conversation. Every chat starts completely fresh. The next video in this series goes deep on tokens and how inference is actually priced. One key API setting is temperature, a number from 0 to 1 that controls how predictable or creative the output is. Low temperature means precise and consistent answers. High temperature means more varied and creative ones. We cover API parameters in detail in the prompting video later in this series. How do you actually use an LLM? There are two ways. The first is a chat interface, a browser or mobile app where you type and the model replies. ChatGPT, Claude.ai, and Gemini are all chat interfaces. They are built for humans. The second is an API, application programming interface. Your code sends a request which contains a prompt and reads the response programmatically. As an AI engineer, the API is how you build things. Your application sends prompts and uses the responses. Your users never have to touch the chat interface directly. Every major model provider, OpenAI, Anthropic, Google, offers an API. The rest of this playlist is about how to use that API well. Now let us look at what LLMs are good at in practice. They can summarize, give me the key points of this report. They can translate. They can answer factual questions. They can write code. They can reason step by step through problems. And they can generate creative text. All of these come from the same mechanism, predicting the most useful next token given everything that came before. But LLMs have real limits that every AI engineer must understand. First, hallucination. An LLM predicts the most plausible next token, not necessarily the true one. It can state false facts with complete confidence and sound very convincing while doing it. Second, knowledge cutoff. Training data has an end date. The model does not know about events after that date unless you tell it. Third, no internet by default. The model only sees what you put in the prompt. It cannot browse the web or look up live data on its own. These are not bugs, they are consequences of how the model works. Understanding them is what makes you a better builder. Two ways to shape how a model behaves. Prompting means giving instructions at runtime, no training needed, fast to change. Fine-tuning means training the model on new examples to learn a specific style or domain. It requires labeled data and compute time. For most use cases, prompting is enough. Fine-tune only when prompting cannot get you consistent results at scale. Prompting techniques are covered in depth in their own video in this series. Here is how everything fits together. 3 layers at the bottom, the foundation model GPT-4, Claude, Gemini used through an API. You do not train it, you use it. In the middle, the prompts and API layer, the instructions, context, and agent loops you design. At the top, your application, the chatbot, the agent, the tool your users interact with. The middle layer is the skill. The rest of this playlist builds it. Here is where we are in the series. You are here, video 1. Next is LLM tokens, cost and context windows. Why tokens matter for every AI system you build. After that, the series covers the agent loop, sub-agents, retrieval augmented generation, and more. Every video builds on the mental model you just learned. If this was useful, subscribe. A new video drops every 2 weeks. Thanks for watching. If this helped, do subscribe to Bits and Proofs. We cover AI engineering, algorithms, and software concepts for people who are serious about building with AI. See you in the next one.